right, of arithmetic number pattern. Let's say we have the arithmetic number pattern or the linear pattern, because that is the same thing. Let's say we got the linear pattern, which is 2, 4, 6, 8, 10. So this is the linear pattern with the first difference of 2, because if I say 4 minus 2, that is 2, 6 minus 2, that is 2, 8 minus 6 is 2, right? So the first difference would be 2. So in order for us to prove that this is the linear pattern, right? Now, let's say now they say, what is the sum? Because remember, the sum is the answer, right, that you get when you're adding, right? So if I'm saying, what is the sum of 4 and 5? Right? So basically, I'm asking you, what is the answer when I'm adding 4 plus 5? Which would be 9. So the sum of 4 and 5 is 9.
Sum of 4
and 5.
and yeah, let's say okay. Oh, like when you add 4 and 5. Okay, yes, yeah,
Yes.
I get you.
Yes. I'm saying a sum, right? If it's saying a summation of two numbers, like I'm adding two numbers. Okay. So a sum is the answer that you get when you're adding. We call it a sum. Right. If you are notice, if you see the first difference, why we are saying the first difference is because the difference is the answer that you get when you're subtracting. Okay? And then the quotient is the answer that you get when you're dividing. And the product is the answer that you get when you're multiplying. Okay? So now, if someone say, what is the sum of the above sequence or pattern? So basically, someone is asking you to calculate, if I'm adding all the numbers in this number pattern, what would be the sum of this number pattern? So basically, if I'm adding 2 plus 4 plus 6 plus 8 plus 10, what would be the sum for this? Right? So you can literally find the sum of any number pattern. But the trick is this. You can easily find the sum of number pattern given the fact that you only have few numbers that are provided in the number pattern. But now when you're dealing with a complex scale, like you're dealing maybe with hundreds terms, right? Now it's time consuming for you to find the sum for that. But as seen now, each general formula to assist us to save time, we also have the formula to calculate the sum of the arithmetic number pattern. Okay? So the formula, we have two formulas, by the way. We have the first one, which say the sum of n is equal to n over 2 into 2a plus d into n minus 1, right? So a still mean the same thing. This is the first number in the arithmetic pattern or the linear pattern. D also mean the same thing, is the first different. And then n, now I want you to note n. N is the total number of terms in the pattern. What do I mean about that? If I'm having the sum, right? I'm having the sum. No. Let's say I'm having the pattern, the number pattern, right? I'm saying maybe I have 50 terms in this number pattern, right? That means my n will be 50, right? So that means I will plug 50 here. Like for example, if someone say find the sum of 50 term of this sequence, let's say for this sequence, and then someone say find the sum of 50 terms of the sequence. So the formula, if I want to find the sum of 50 terms, right? Basically, if I'm doing that physical, I have to add, like I have to start by finding. You can see with that it's time consuming because this is term 1, right? This is term 2, this is term 3, this is term 4, this is term 5. So I have to find term 6, term 7 up until term 50, right? Which I can do it, right? Because I can use the formula of Tn equal to A plus D into n minus 1, right? I can use this formula to find any term in this pattern. So I can find term 6, term 7, term 8, term 50, and I add all of those numbers. And you can see that is time consuming. So in order for you to save that time, we use this formula, right? Like for example, if someone say, find the sum of 50 terms, you can just quickly use this formula right here and they, oh, okay, they want the sum of 50 terms. So I will say sum of 50, like for example, the sum of this 50 term of this pattern. So sum of 50 is equal to 50 divided by 2. I'm using this formula right here, right? 50 divided by 2 into 2 into A. A is the first difference, which is 2, right? Into 2, right? Plus, no, sorry. Not A is not the first difference, it's the first term in the pattern. Or which always happen to be 2
Yes.
also. It's happened to be 2, right?
Yes.
Okay, and then D is the first difference, which is also 2. So it's 2 into 50 minus 1 in bracket. And then this would be 50 divided by 2, which would be 25 into 2 times 2, that is 4, plus 2, 50 minus 1, that is 49. So it times 49. Right? So you can easily calculate this, punch calculator, and then that would give you an easy answer. If you now calculate the 4, then 2 times 49, Uban.
2 times 49 is 98.
98, and then 4 plus 98
is 102.
102. So 25 times 102 is what?
It's 2,550.
2,550. So if I'm adding, what does this number mean? If I'm adding the term starting from term 1, right? Starting from here, starting from this 2 right here, right? If I'm adding starting from this number, which is 2, and up until I add the term of term 50, I will get 2,550. But you can see that is now, in order for me to save time, I just use this formula, right?
Yes, no. I know, I get you.
Right. Now, this is the first formula on I7s. Now, the second one that you can use, which is also the same thing, there's a formula which is Sn equal to n over 2 into A plus L. Okay, so n is still means the total number of the term in the number pattern, right? So basically, n is the number of the terms at which you want to find the sum for. If you want to find the sum of 50 terms, n is 50. If you want to find the sum of 200 terms, n is 200. Okay, now a still means the same thing. A is the first number or the first term in the sequence or in the pattern. Now, the trick is this. Let's say we have a pattern, right? We have a pattern, let's say the pattern that we have is 2, as I said, is 2, 4, 6, 8, 10. And then let's say you say something like this. There was something like this. Most of the time they would use plus, by the way. They would use plus. If they use plus, it's still the same thing, right? They would use plus, which that tells you that that's the sum. And then they will say and then they will say plus, and then they are saying 200 here. Okay? What does this 200 mean? This 200 means that the last term, right? The last term in the sequence is 200. Okay. So your terms will start from 2 to 200. But we don't know what is the position of this term. But we can actually find the position because we know that the Tn for this, if we calculated this yesterday, is we got 2n. So if we found a position number band, we can plug in that 200 here and find n. So if we plug in 200, 2n, and then we divide by 2, so we'll get that n is equal to 100. So basically, right, I have term 1, term 2, term 3, term 4, term 5, up until term 100. So the last term is 100. Khona umbuzo nawo la?
No, I get it. Yeah.
So if I'm saying to you, find the sum of this sequence of this number pattern, basically you know that okay, if the last term is 200 and the last term is 100, that means you want me to find the sum of 100 terms because the terms that are here are 100. Do you understand what I'm saying?
Yeah.
So now, so in order for you to find the sum, you can use, okay, now how can you apply this formula, right? This
Yes.
L is the last term in the pattern.
Okay.
So the last term is
Okay.
this, which is 200. So once you have the last
Mm,
term, you can use this. You'll only use this formula when you have the last term in this, because this is the shortcut formula, right? I would not, most of the time I
mm,
won't suggest you using this formula, but in some cases it would be important for you to use this formula because Lana, that's the only option I have, right?
mm,
So now to calculate the sum of this pattern, that given that the last term is 200, so I will have ace of 100 terms is equal to 100 over 2 into the first term is the first term is 2, right? So this would be 2
mm.
plus the last term is 200, right? Which would be 100 divided by 2, that is 50 into 202. And then 50 times 202 ba.
Angza,
50 times 202 ba.
is 4040.
4000,
4040.
4040.
Mm.
4000. Okay. Kusho ukuthi a sum of all this term, because if ngithi last term is 4040. So this is how summation isebenza kanjena ke. This is for i-linear pattern or i-arithmetic pattern. Sisazoyibuka mase sikhuluma nge-geometric pattern or geometric pattern, geometric
Okay.
number
Okay.
pattern. So khona umbuzo nawo la.
No.
Let me try to get a question